Here we have the graph of y equals x squared minus 1 over x. We're interested in roots of the equation. In other words, we're interested in where x squared minus 1 over x is equal to 0. More generally, we're looking for solutions to f of x equals 0, and f of x in this case is the x squared minus 1 over x. Where this is 0 is where it crosses the x-axis. We can see quite clearly here that this happens at 1. It's worth noting here that the curve is below the axis to the left and above the axis to the right. Generally with roots, they either do this, or they're above to the left and below to the right. In this situation, let's suppose this value is a, we would have f of a is negative, and here, let's suppose this value is b, we have f of b is positive. So we have a change of sign, and the root is between a and b, where we get this change of sign for the function. In this situation, it would be the other way around, positive here and negative here. Nevertheless, we can see the change of sign as we go across the root, and this is an important point. With the simple iteration method, rather than considering f of x is 0, we rearrange to give x is equal to a different function of x. For example, here, in the case of x squared minus 1 over x equals 0, we could rearrange that to give ourselves x squared equals 1 over x, and that rearranges to give x is 1 over x squared. So in this case, this is our g of x, 1 over x squared. Of course, there are other arrangements. For example, we could have said x squared is 1 over x, and then said that x is the square root of 1 over x. In this case, this one would be our g of x. Now here we have the graph y equals x and y equals 1 over x squared. The point of intersection is where x equals 1 over x squared. In other words, x equals g of x. Notice that this happens at 1, and this always happens. If we look at the original graph, y equals f of x, any time that f of x equals 0, if we've done a correct rearrangement, at the same point, y equals x and y equals g of x will intersect. That's the same x coordinate. And this is where we home in when we use the x equals g of x, or simple iteration method. There's basically 3 steps. First of all, we need to identify y equals f of x. Remember, we're looking for f of x equals 0. This may require rearrangement. For example, if we were given x squared is equal to e to the x to solve, then we'd be looking to solve x squared minus e to the x equals 0. So we'd have y equals x squared minus e to the x, and this would be our f of x. Now step 2. We look for a change of sign. We discussed this earlier in the video. If we have a root here, then the curve could be below here and above here. And this would mean that f of x was negative, and this would mean that f of x was positive. If this value here is a, and this value here is b, then we'd be finding an interval, a, b, where there is a change of sign. The curve might slope the other way, in which case it would be positive here and negative here. But the point is that the root lies between a change of sign, so we can identify an interval in which the root lies. This method then relies on rearranging f of x equals 0 into the form x equals g of x. And this is what we use in order to get a better approximation to the root than the values we have here. Often it can be arranged in different ways, and we saw that earlier in this video as well. But the crucial thing is that if the rearrangement is done correctly, then the root will be in the same point. The intersection of y equals x and y equals g of x will be at the same x coordinate as any roots of f of x equals 0. We'll see this in action over the next few examples. So hopefully, if this isn't clear to you at the moment, it will become clear when you actually see it in action.